Hey, Miss Brown's class. Today we're going to talk about linear functions. First of all, what is this weird word linear? All right, notice it has the word line in it. So we're going to be looking for a function that forms a straight line. Okay, so that is our first criteria. If your graph has a curve in it, it is not a linear function, and that's going to help you figure out half the questions on your iReady assignment for this week, so you're already set. All right, y equals 4x minus 2. So there's two ways that we can go about graphing this, and your Khan Academy assignments are going to take you through this. Okay, when it's written like this is called y-intercept form. Y-intercept form means that this minus 2 right here is our starting point, and that's a y-intercept, meaning it hits the y-axis at -2. So you can make a dot there. Now, this is giving you a play-by-play of what to do. 4x is your slope, and remember we said slope is rise over run. So that means rise 4, run once. So from that -2, I would go rise 4, 1, 2, 3, 4, go over 1, make a dot. Rise 4, 1, 2, 3, 4, over 1. Okay? Then I could connect those dots into a nice straight line. Now, another way that I could solve this or figure out what points are going to go on that graph, if I'm drawing something by hand and I don't have actual graph paper to work, the way that I could figure out what ordered pairs would go in this value is if I'm working with a table of values. Now, what does that mean? This is saying 4 times 0, I'm just plugging in any number here. Okay, I like plugging in small numbers because it's less for me to think about. 4 times 0 is 0, right? So 0 minus 2 would equal -2. Now, do we have that ordered pair? Go out 0, down 2? Yes, we do. All right, let's try it with some other values. If I plugged in a 1, so what's 4 times 1? And then subtract 2. So 4 times 1 is 4. Minus 2, that's a positive 2. So do I go out 1, up 2? Yes. Let's try it again with a 2 here. 4 times 2 is 8, minus 2, that gives us a 6. So did I have the point 2, 6? Yes. These are ways to go ahead and try that process. Now let's try another equation. Let's make it a negative slope just for fun. All right, we're going to do it once again, both ways, by doing the graphing starting at our y-intercept. So start at 3. And then you're going to go down 1 over 2, down 1 over 2. That's what your slope is telling you. So start at 3, down 1, over 3, or over 2, I'm sorry, I can't count. So, starting at 3, that's our y-intercept, so it crosses our y-axis. Now down 1 over 2, down 1 over 2, down 1 over 2, has more of this look to it. Once again, you can take your ruler, make a nice straight line going through that. When you get into Algebra 1 next year, you guys are going to be figuring out solutions where these two lines cross, basically figuring out what that point is. We don't need to do that yet. But I just want you to see the difference in shapes of the graph, okay? If it's a fraction as the slope, it's a flatter line. If it is a whole number, a number greater than 1, your slope is more upright, more vertical. Okay, so those are some patterns to look for. Now, let's go ahead and try a table of values here. So what happens if I plug in different numbers? Now I know on the last one, I did 0, 1, and 2. I could still do those same numbers, but because my slope is 1/2, I'm going to try it with even numbers because when I cut an even number in half, it comes out to a whole number. Whereas if I do what's 1/2 of 1, then I'm dealing with a decimal or a fraction. It's doable, it's just a little bit more thinking. So start off with 0 because it's always good to know what your y-intercept is. And then let's pick a few even numbers. So what is 1/2 of 0? Still 0. 0 plus 3, 3. So do we have a point 0, 3? Yes. All right, now if I try to put a 2 in there, what's negative 1/2 times 2 plus 3? Negative half times a 2 is a negative 1. Negative 1 plus a positive 3. If I was looking at my number line, start at negative 1 and go 1, 2, 3, that's a positive 2. So do I have the point 2, 2? Out 2, up 2. Yes. And then let's try a 4. Once again, I'm trying even numbers because that way they aren't on a half like you see in this graph. That way we're only looking at exactly where it hits the corners in the graph. So negative 1/2 times 4. So think about what's half of 4, which is 2, but turn that into a negative, so it's negative 2. And then plus 3. So negative 2 plus 3. Once again, you could use your number line. Start at negative 2, go over 3. 1, 2, 3 to the right. It's a positive or adding, so that's why we're going to the right on the number line. So that's positive 1. So do we have 4, 1 on here? Out 4, up 1? Yes. So all of our values are checking out. Whether we did a graph, just counting it, down 1 box over 2, or if we made our table of values. Either way, you should get the exact same results. Now, some of your questions on iReady are going to ask you if a picture is a linear function. So I'm going to draw in a couple different colors. Very exciting stuff here. These are all the same color. And I'm going to show you examples of nonlinear functions. So remember, linear means it's a straight line. So literally anything that isn't a straight line. Next year in Algebra 1, you guys are going to be doing parabolas, which are going to look like U-shaped graphs for you. Okay? If your graph does what this red line does and it's a U, it's not linear. Also, if your graph changes directions partway through, so if it was going on a straight line and then it kind of takes a dip and then it goes back on a line, that's not straight. It made a little turn in there partway through. I know part of it is a line or a line segment, but not the whole thing. So a linear function, you want the whole situation to be a straight line all the way through with no curve. The way that you would get a curve in your graph is if you had an x squared. So if you said that marker's dead. If you said x squared plus 2, x squared plus 2, this would be curved. So anytime the x has an exponent, that means it's curved. If the x does not have an exponent, like these first two examples, it's a linear function. So